Hi everyone, welcome back to Data Cadence. My name is Rahul and I work as a senior applied research scientist. And in this video, we are going to deep dive into one of the most crucial concepts in deep learning, that is dropout. Now, whether you are new to neural nets or a seasoned data scientist, this video will help you understand what is dropout and a pivotal role that it plays in today's modern day neural networks. In this video, we are not just scratching the surface. You might have heard about dropout before, but we are going to explore dropout in detail, right from the fundamental principles to the advanced techniques. We'll break down how dropout works, why it's essential for preventing overfitting, what's the intuition behind dropout, why does it work, and how does it contribute to building a robust and generalizable neural nets. For those of you who already have a good grasp on dropout, I think this would be a good opportunity for a thorough test and revision of your knowledge. We'll cover everything you need to know. And this is often another important interview questions because dropout is a very fundamental concept which was introduced when we had artificial neural networks, and it's still used in some of the state of the art and modern transformer architectures that we see today. So without further ado, let's begin. So the first question is, what is a dropout? So dropout is a regularization technique used in neural nets to prevent overfitting. Overfitting happens when a neural network performs very well on the training data but often fails to generalize to new or unseen data, that is also known as test data. And this occurs when the model becomes too complex and it essentially learns the noise and details in the training data rather than the actual underlying pattern, or rather than trying to learn how to generalize on newer and unseen data, right? So during the training phase, the random neurons in a neural network are dropped out with a certain probability, also known as the dropout rate or the dropout ratio. And an example could be say 50%. And their contribution to the activation of downstream task is temporarily removed. And that's what happens when you drop out a certain set of neurons with a probability. And this prevents the network from being too dependent on any single neuron, forcing it to learn more robust and general features. And this is the intuition behind dropout, that when you're removing a certain set of neurons, so the network stops being dependent on any particular neuron or any single neuron, and therefore it learns a more robust and general features in order to learn the underlying distribution or the underlying data pattern, right? Now, how does dropout work during training? So imagine you have a simple neural net with multiple layers of neurons, all fully connected layers. At each of the iteration in your forward propagation, you would drop out randomly, and the dropout would essentially select some neurons randomly and set their output to 0. And the network then learns to not only rely on any specific neuron like we mentioned, but rather on a set of more distributed set of features, considering different neurons and different connections, right? So on the left side, you have a normal neural network. Excuse my bad drawing. But yeah, on the left side, you have a normal neural network. You have, say, some hidden layers that you can see, and these are all fully connected or dense layers where you see that each neuron in one of the hidden layers is connected to every other neuron in the next hidden layer. And this is how a normal neural network would look like. Whereas what happens in dropout is you see these red neurons that I have marked with red color. So essentially these neurons is what you deactivate, or in other words, you set their particular output to 0. And what essentially happens is that the connection to these neurons is then removed. You can think of this like these particular set of neurons no longer exist in that particular layer. So the connection is also removed and their output is set to 0. That's how you would achieve dropout. And how do you select this percentage of neurons that would be randomly switched off is what is decided by the dropout ratio or the dropout percentage. But you get the idea. If you have a look at the figure on the right, you will see that there are no connections, no incoming connections to these particular neurons because virtually they do not exist in the network, right? So this is what happens when you apply neural net after dropout. And basically it's clear from this particular diagrams that how does dropout work and what actually happens when you apply dropout to a neural net or a hidden layer in a neural network. Now, one of the most important things that is often asked during interviews, and it's also very important to understand, is what happens during inference. So whatever we saw above was applicable for the training phase, but what happens during the inference phase, and that's where a lot of the concept sort of kicks in. So during the inference phase, dropout is not applied. That is the first thing that you need to know. Why it happens, we'll talk about that. But you need to remember that during inference, you do not apply the dropout. And why? There are two reasons for that, and there is also some other things that we will talk about. So let's talk about the reasons first. The first reason is consistency. So during inference, you want the network to be as consistent as possible and utilize all the learned features that it learned in the training phase in order to make accurate predictions. And that is the first reason that in order to maintain that particular consistency in the network, you would not want to apply dropout during your inference phase. The second one is stability. So dropping neurons during inference could lead to unstable outputs since the network wouldn't have the same architecture it was trained with. So stability is another big reason where because of which you would not want to apply dropout during your inference phase. And there is another important catch here. So all the neurons are active, but their outputs are scaled down by the dropout probability. And that is one of the most important things that you need to understand, that even though all your neurons are active during the inference phase, but still the output from each neuron is scaled down by the dropout probability, because this scaling ensures that the predictions made during the inference are consistent with the training process. So for example, if you have a neuron which outputs say 4, and how does this 4 come? It's pretty elementary. You apply an activation function to the linear combination of your weights after adding a bias. That's how the neural network works, right? And say output of a particular neuron is say 4, and say for example that your dropout rate was say 0.5, then you multiply this particular 4 with the 0.5 to end up with 2, and that's how the scaling is done. Now the next question might be, how do you implement this particular scaling? So luckily you don't need to implement this manually. The dropout layers in some of the most famous deep learning frameworks, including TensorFlow, Keras, and PyTorch, handle this particular thing internally by adjusting the weights during inference to account for the dropout applied during the training. And this is taken care of, in other words, right? The next question that you might ask is how to identify the optimal dropout ratio. So think of dropout as another hyperparameter in your neural network, and that's where you can use the regular things like cross validation and other techniques that you use for optimizing your hyperparameters. But there are certain guidelines that I would like to share. So typical dropout ratio that is used in neural networks is between zero point 0.2 to zero point 0.5. And like I said, there is no fixed rule. These are just guidelines based on experience and based on different scenarios, right? Because specific choice of your dropout ratio or your dropout rate will depend on various factors, including say architecture of the network, size of your dataset, amount of overfitting that you are observing. So typically 0.5 or 50% dropout is one of the most common ratios that we see, particularly in dense layers or the fully connected layers, in other words. This provides a good signal between regularization and retaining enough signal for learning your useful features. Then you do have the zero point 0.2 to zero point 0.3 dropout that is typically used in convolutional neural nets or CNNs. And how is dropout applied to CNN is a different thing. I'll briefly touch upon that. But zero point 0.2 to zero point 0.3 dropout is typically used in CNNs, where a higher level of feature preservation might be beneficial. And above zero point 0.5 dropout is very less common, and it's rather rare, I would say, because dropping too many neurons can lead to underfitting. If you have a very simplistic neural network architecture and you drop out most of the neurons, then essentially you would not be able to learn any of the features in your underlying data. And that's why you would see that above zero point 0.5 dropout is relatively less common and rather a rare phenomenon. So I was talking about dropout in CNN. So in traditional fully connected layers, dropout is commonly used by randomly dropping out a certain percentage of neurons at each training step, like we saw. So this forces the network to basically rely on a wider set of features, which indeed reduces the overfitting. In CNNs, the convolutional layers that you have are responsible for detecting local patterns such as edges, textures, and shapes by applying filters or kernels, which is essentially the matrix that you learn across the input image. And when dropout is applied to the convolutional layers, instead of randomly dropping individual neurons, it typically drops the entire feature maps. A feature map is the output of a filter or a kernel to the input image, representing a specific feature detected by that particular filter. So that's briefly how dropout works in convolutional layers. And like I mentioned that you might want to use zero point 0.2 to zero point 0.3 dropout because you might want to preserve some of the features or the textures or the edges or shapes that this convolution layer has learned, and therefore a very high dropout value is often avoided when you're using CNNs. And now there are certain things that you need to consider for choosing a dropout rate. I'll just summarize what we discussed. So some of the parameters that we discussed were often say network size. So larger networks with more parameters are more prone to overfitting. So the more complicated your model is, the higher are the chances that it would overfit. And higher dropout rates like zero point 0.5 are often used for larger networks. Then the second one is task complexity. So for simpler tasks or smaller data sets, a lower dropout ratio might be sufficient enough. And the last one is the layer type. So like we mentioned, convolution layers typically use lower dropout rates, sorry, say for example between zero point 0.2 to zero point 0.3, whereas fully connected layers might use higher rates such as 0.5. And like I mentioned, you can also do experimentation, so you can often determine the dropout ratio empirically. So the data science practitioners might typically try a few different dropout ratios and then observe the model's performance on a validation set to choose the best value for their dropout ratio. And like I said, essentially dropout rate is also a hyperparameter, and this can be determined via things like cross validation. So in this particular video, we tried to go deep into dropout and tried to understand a few of the things in detail, which will help you in a day-to-day workflow as well as in a lot of the interviews, because having a fundamental understanding of dropout means that you are well aware about the deep neural networks. And like I mentioned, dropout is still used in a lot of the newer age architectures and a state-of-the-art architectures, including transformers that you see today. So it's good to know about dropout in such detail. It also gives you a better understanding of what you do in a day-to-day work in case you use dropout layers in your deep neural nets. And I hope that this particular video gave you good insights about this particular topic. And that's what the goal here is. In this particular channel, the whole aim is to make you understand what you are using so that you also feel comfortable in your day-to-day work, as well as if you are appearing for interviews, you are well prepared to answer some of the most commonly asked questions, and these are expected from a data scientist. So yes, if you like this particular video, do give it a thumbs up and subscribe to this channel for more such content around interview prep, deep learning, machine learning, statistics, generative AI, and a lot more. So see you in the next video then. Thank you for sticking till the end. Until then, take care and keep learning.